Hi everyone, I'm presenting my project, which is the scientific paper's AWS ETL pipeline. This data engineering pipeline extracts, transforms, and loads journal articles related to the specific topic, CAR T cells, from the preprint server API into Amazon S3. CAR T cells are genetically modified immune cells that are used to treat cancer, so they're definitely a topic of interest. Let's look at the ETL pipeline design diagram. I use Lambda to extract journal article data from the medRxiv and bioRxiv API into an S3 raw data bucket, running on a daily EventBridge schedule. I then use AWS Glue to transform the raw JSON data and store the clean data in Parquet format in the S3 clean data bucket. Athena can be used to infer the schema of the clean Parquet data and run SQL queries on it. QuickSight allows us to quickly visualize the clean data in a dashboard. The clean data should have the following information, like title, authors, word count, and dates. To go one step further, we can load the data into a data warehouse with facts and dimensions like this in Amazon Redshift. Let's dive deep into the extraction part. There's a Lambda function each for bioRxiv and medRxiv. In the function, I create or retrieve a bookmark in S3 raw bucket that stores the preprint date of the last article we look at. The function then gets a list of journal articles for the next date from the API. We loop through each article. If the title or abstract contains the keyword CAR T, we store them in JSON format in the raw bucket. If not, we ignore them. For initial extraction, we use step functions together with Lambda to retry the Lambda function until all dates are caught up. We then do incremental extraction by scheduling the Lambda function to run daily on an EventBridge schedule. At this point, we can use Glue Crawler to determine the schema of the raw S3 data, store them into bioRxiv and medRxiv Glue tables, and use Athena to analyze data directly using SQL. Next, I use a Glue job to transform the raw JSON data and store the clean data in Parquet format in an S3 clean data bucket. The Python script first combines the medRxiv and bioRxiv Glue raw tables together into one single Glue dynamic frame. Then it removes the null rows and drops duplicates of the same article, only keeping the latest version of the article. It drops unnecessary information from the raw JSON as well, like license and XML path, and renames existing columns into more descriptive column names. With the Python package PyMu-PDF, we access the PDF of each article in the raw bucket and get the keyword count and total word count of the article, storing them into columns. Afterwards, we add the breakdown of dates, where we extract the date string and store the day, month, year, month abbreviation, quarter, and day of week into new columns. Finally, we load the dynamic frame into Parquet files in the S3 clean data bucket, partitioned by year, month, day. The job is scheduled to run every day. A Glue table with partitions is automatically created and updated as well. So Athena can be used to analyze the clean data with SQL. Finally, in QuickSight, I use the clean data Glue table as the dataset and visualize the data in a dashboard. For example, here we have the count of CAR T journal articles per year in each preprint server, a scatter plot of keyword count against total word count, and count of records by category in a pie chart, etc. QuickSight is a very useful business intelligence tool for data analysts to make plots easily from the Glue tables or other datasets. And this concludes how the whole ETL pipeline works.